Now let's continue to finish this section. So here we have a definition. It's called the rank of a matrix. So the rank means the number of the non-zero rows in the row echelon form. So let's take a look. Definition form. So the number of non-zero rows in any row echelon form of a matrix is called the rank of A. So, and we denote this as rank A. Okay, notation, rank. So let's take a look at an example. We want to determine the rank of a matrix A if the matrix is given. So let's take a look. So we just need to find the row echelon form and then decide how many non-zero rows. We can take a quick look. So let's see, we have so many. Let's take a look at this exercise. So the rank for this matrix, you know, the row echelon has 3 non-zero rows. So for this one, the rank of A is 3. Right? Rank is 3. Now let's take a look at some other row echelon form at beginning. Let's see, we have several problems here. Okay, let's see the exercise 1 problem. The rank is 1, right? Because only 1 non-zero row. And for the second problem, we have 3 non-zero rows. So rank of A is 3. Just something like that. Okay, now let's take a look at example 4. Determine the rank of A if so we cannot tell the rank from the original matrix. So we have to reduce this into row echelon. We have to change this into row echelon. It's kind of like a simplified matrix, and then we can tell. Okay, so now the first step, we need to reduce this to row echelon. Let's a quick review what we did in the last week. In the last class, we just need to use row operation to make this into row echelon, right? So firstly, we need a leading one in the first row, and we noticed there is 3, there's 2, so I want to use -2 add to 3 to make a 1 in the first row. So let's see. Okay, equivalent to, so use the row 3 times -1 add to row 1. So it's like row 3 still keep the same thing, and row 2 same, but row 1 has been changed into 1, and -1 should be +1 and 2. Here should be 1, right? After we have leading 1, we can easily make them into zeros because we can just use the row 1 times -4 times -2 add to row 2 and row 3. So row 1 doesn't change. 1 times -4, 0. 2 times -4, -8. 1 times -4. 1 times -2, 0. 2 times -2, -4, -5. 1 times -2, so there should be 1. Okay, and from here you can see actually row 2 and row 3, they are the same thing. In the future, whenever you see like same rows, you can just make the last row to be 0, because you can use row 2 times 91 add to row 3, right? So like row 2 times 91 add to row 3. So because they're the same thing, you can just make the row 3 to be 0 and 1 2, 1. And in order to make the second into row echelon, we need to change this into number into 1. So we need to divide by -5. So this is the row echelon form. Okay, row echelon form. So from here we can see the rank of this matrix is number 2 because there are 2 non-zero rows. Okay, let's take a look at this exercise problem. 2, -1, 3, 3, 1, -2, 2, -2, 1. Please find the rank of this. And this kind of problem will be in the quiz. So here's the solution. With the row 1, the 2 make the 3 into 1. Okay, so we use the row 1 keep the same, and the 2 times -1, 91 times -1 become 41, and there are 2. 3 times -1, 95. Okay, and then we switch the row 1, row 2. So because we need a leading one in the first row. Then use the row 1 times -2, add to row 2, row 3. 0. 0, -6, 11. And next, we need leading one in this position. So how to make that leading one? We can use row 3. The -6 at there. So let's see. Row 3 times 91 add to row 2. 0, 1 times 91 and there should be 2. Right? And then at the end, 1, 2, 95, 0, 1, 2. Use this number, make that into 0. 1 times 6, 2 times 6, 12, 23. And if we want to further simplify, you can make this number into, it's not row echelon yet. So 0, 0, 1, this is row echelon. So we can see the rank for this one, there's no 0 row. The rank for this one is 3. Okay. Last definition is called reduced row echelon matrix. Let's take a look at the definition. Reduce the row echelon matrix. I'm going to give you some idea what's the row reduced row echelon look like. So it's going to be like if we have a row echelon, it look like 1, 2, 3, for example, 0, 0, 1, like this, right? And the reduced row echelon means in each column, except this leading one, all the other numbers has to be 0. So like those has to be 0. Okay. That is called reduced row echelon. Let me give you the definition. And let's see. 2 conditions. Firstly, it has to be a row echelon. Reduced means either than row echelon. Okay. Next, any column that has leading one has 0 everywhere else. Any column that contains a leading one has 0 everywhere else. Let's take a look at some examples here. 1, 3, 0, 0. Let's tell if they are reduced row echelon or not. Let's see. Okay, the third column is not very good. Third column is here. Let's take a look at. Firstly, we need to see, is this row echelon form? Yes, this is a row echelon. And we can next find the leading one. Here's leading one, and the leading one. And then now we look at the column position in the column way. So in each column, except this number 1, all the other are the other numbers 0. Let's take a look. Yes, this is row echelon. Okay, reduce the row echelon. Let's see. 0, 91, 7, 0, 0, 0, 0, 1. So, okay, this is number 1. This is a row echelon, right? Row echelon form. And there are only 2 leading ones. And so in the column 1, column 4, 1 is the only number. That is also reduced row echelon. Let's take a look at another one. Is this a row echelon? Yes, and only 2 leading ones here. So in the row column 1, column 2, 1 is the only number, non-zero number. So those are the examples of reduced row echelon. Okay. Now let's take a look at the example. We are going to find the reduced row echelon form for a given matrix. Example 5. Determine the reduced row echelon. This matrix is given by this 3, 91, 22, 91, 5, 2, 2, 4, 24. Okay, so same thing, we just do row operations. Now let's see. Firstly, we need a leading one in the first row, so I'm going to permute row 1, row 2, and we can also multiply the row 1, row 2 by -1. So 1, 95, 92. That is row 2, and permute with row 1. 3, 91, 22. 2, 4, 24. Next, we need to make them into 0. Right. Okay. So I skip the procedure here, the notation. That's like, you can try to write down by yourself, but we can save some time. 1 times -3, 0. -3, 15, 15 minus 1, 14. Here, 28. 1 times -2, 0. 95 times -2, 10. 10 at there, 14. 92 times -2, 94 at there, 28. Right? So, as I said before, you can see, actually that's positive 28. Row 2, row 3 are the same thing. You can just make row 3 into 0, and row 2 we can divide by 14. So here is the row echelon. But we need a reduced row echelon. So for the reduced row echelon, what do we need? We have 2 leading ones, right? And in the second column, we need the list number to be 0. How to make that into 0? Same as before, we use the second row times +5. We use that 1 to make that into 0. Okay, use row 2 times 5 add to row 1. Or we can write down this row 2 times 5 add row 1 times 5. Okay, let's write down. So row 2 keep the same, and row 3 0 zeros definitely doesn't change. So row 1 become, because they are all zeros, so they don't change the number 1. Okay, still 1 there. 1 times 5 there will be 0. And the number 2 times 5, 10, 10 minus that, 8. So you can see This is the reduced row echelon form. Okay, this is the reduced. You can try this exercise problem. This is given matrix like this. Okay. I'm going to give you the solution here, but you should practice this by yourself. This is number 3. You may do different way. There's no unique way to change this into row echelon or reduce the row echelon. You may get different answer, but the rank is always the same. Let's see. I'm going to permute row 1, row 2, or row 3, because I need a leading one. Row 2 is still same, and then I use this one to make them into 0 times -2 times -2 times -3 times -3 -3 at there 7. Next, we need a leading one, and then we need a leading one in the second row. 0, 1, 3, so just change it to positive. Next, I'm going to use this one to make them into 0. Something like this. So row 2 times -2 add to row 1. 0 times -2, -6 add there, -5. 0 and 0, this times -1, right? So it should be 4 here. And is this second column is okay, but we don't have leading one in the last row, but we can just, because it's 0, 0, 4, we can just make divide by 4, right? Divide by 4. So 0, 0, 1. Okay, and from here, next we use this one to make them into 0. Row 3. And 1 times -3. Yeah, make that into 0. Because row 3, the both are zeros, they don't change the first number, so we can just make them into 0. So this is the reduced row echelon